Hopefully, I've impressed upon you the importance of control and of using modulation at all different levels of signal generation in order to get more interesting and rich sounds. So now we're going to look at hierarchical control, the idea that you can be controlling parameters at many different levels of musical structure. And the ideas are simple, and we'll look at some code examples. You know that control functions from PWL and LFO can be passed as parameters and returned from functions. And they are of type sound, just like audio, so they're sampled signals. And what we want to do is illustrated down at the bottom here. Imagine that these little segments represent notes or some kind of sound events in sequence, and we have some parameters that are modulating or changing over time on an event-by-event basis. But we might also want to have some kind of global control of how things vary over time in terms of a larger structure. We can combine those simply by multiplying these envelopes. So now what remains is to look at some specific examples just to show how these things can be constructed. To begin with, we'll start with simple event-by-event modulation like we've seen before. So I have a function called frequency modulation. It's constructed with a PWL function. And I have a function called VibTone that calls upon fmod to do frequency modulation. And now we're going to play a sequence of these. Okay, so that was a grossly exaggerated frequency modulation, just so you can hear exactly what's going on. You notice that in each note we have this ba thing that repeats identically on each note. So now we're going to try to, instead of applying that shape to each note, we're going to apply that shape to the entire phrase. And to do that, we change our synthesis function a little bit to take a vib parameter as a sound. And the important difference here is, whereas before we just took 40 times the function, now we're taking const of 40 times the function. So why would we do that? Well, it turns out the duration of fmosc is determined by the modulator. What we want to do is pass in a very long sound, but select out only the portion of that sound that applies to the current note that we're synthesizing. One way to do that is const is a function that builds a rectangular function that has the duration of the current environment. So if we stretch this thing, const gets larger. If we stretch by a small factor, const gets shorter. But anyway, so we have 40 with a finite duration, and so when we multiply this rectangular shape of height 40 times this arbitrary function vib, it's going to clip vib to exactly from the start time of our tone to the ending time of our tone. Okay, so now we're going to take our modulation function, stretch it by 3, assign it to a variable, and pass that same modulation function to each instance of VibTone. Each VibTone is happening at a different time, though, so it's going each instance of VibTone 2 is going to select out a different portion of that overarching vib modulation. So let's play it. Okay, so now you hear that this overarching modulation that's 3 seconds long is being applied sort of piece by piece to the underlying phrase. Okay, so that was constructed to make it easy to hear what's going on, and I hope that was clear. So now we're going to look at something a little more musical. In this case, we're going to use a real vibrato function, and we're going to have an overarching envelope to control the intensity of vibrato through an entire phrase. And we're also going to have an overarching amplitude to modulate the entire phrase. And I won't go through this in as much detail as before, but here we can see Vib intensity being constructed it'll be global relative to this sequence, and we have this global amplitude function, and we're just going to multiply the global amplitude modulation by the entire phrase that we construct with sequence. And I guess the other thing I should mention is up here, where we construct an envelope, we are taking the Vib intensity, which is this global overarching intensity function, and multiplying it by a local smooth to vibrato function that's actually contains the LFO to do the vibrato. All right, so let's play this. And what you should hear is slightly increasing intensity of vibrato through the second note of the phrase, and then decreasing after that. And you should hear the overall amplitude growing and coming back down. Okay, so the point of all this is that you can use control functions like PWL and constructing them by other means, and build control at the phrase level, pass those sounds in as parameters to achieve control at different levels.